Well, greetings and salutations. Well, guys, well, Antonio's got me beat. Um, I don't really know what to say. Um, it's a little embarrassing, but Antonio came to my page just a couple minutes ago, and since I happen to have a minute free, I thought I'd point this out. Antonio pointed out to me that in the video that I was doing about the Mount St. Helens stuff, he says, as I commented to one of your half-wit fans, thank you, LOL, his videos are gold to the flat earthers who pay attention. And note how his camera elevation was 700 feet higher than the real elevation. This is in the Mount St. Helens thing. The real elevation was 1,075 feet, not 1,706 feet, as he input. Raising the camera makes the bulge shallower. And despite all this, he failed to have the line of sight meet the top of the side peak at Mount. Well, okay, line of sight. That's the new rage now. Flat earthers think that the direction that you point the camera is going to have some effect on the elevation relationship of different items, which I find hysterical. But Alicia, and but you know, he did get me on this. He got me on this right here. 1075 versus 1706. Now, apparently, in my zeal to get this done quickly, because yes, in the original video, it says picture elevation 1,075 feet. It does 100% say that. And as it appears, I went back and I checked my model because I save all these models. Yeah. As it appears, I did fat finger the number. Now let me show you what that brings. You see, now let's get some numbers here out of the way first. Hold on. Just kind of doing this spontaneous. So let's see what we got here. Now, feet to meters. Because I always do meters in my 3D work because of the fact that A, it makes more sense, and B, because it is in decimal units. So, feet to meters. Now, the feet involved here are 1,075, which is what is actually written in the video. Okay, the video says 1,075 feet. So 1,01075. Now, mind you, this is much more accurate than anything that your ex-boyfriend's ever done on his show. But nevertheless, so 327.66. So we're going to go ahead and put that into the notepad as the correct height. Okay. Now, he states that I said 1,706 feet. I'll go with that, judging by what I just looked at on the model. Okay, so 1,706 feet. 1,706 is 519. We'll just call it 520, which is what I believe I did in the video. 520. Let's go for 520. Wrong height. Okay. Oh. Now, what you're about to see is somebody do something that you never see a flat earther do. See, first of all, I'm not too big to admit that that was wrong. And in the bigger picture, it would be very easy to say that that represents an enormous difference. Right? Okay. So, let's bring up the model. This is the model I was working with. Actually, I think this is the one that I built live for Riley. Oh, no, I expanded upon it for Riley because we were talking about all the other different aspects of angular size and blah, blah, blah. But nevertheless, just to show you, okay, camera, tape. Now, if I go up to here, 52, okay, which is 520 because the whole units are single kilometers. So that's 520 meters. Okay, that's on the flat, or that's on the flat cam. Let's go to the curve cam. Okay, tape. Just showing you that, yes, it is correct that I used that height. Cool. Everybody sees that, right? Now, yeah, I punched in the number a little bit screwy. But let's make the correction. Okay, because that's what we're supposed to be doing here. 520, you just saw me bring them out on each one. 520 for this one, 520 for this one. So let's move them down to, let's just round this up to a nice 328. Okay. Or you know what? Screw it. Seeing that he says I'm too high, we'll even round it down to 327. Leave it straight at 327. Even though it would round up, we'll just leave it there. Okay, 327. So let's go ahead and shorten these, each one of them, to 327. Okay. Now I started typing this in a minute ago because I wanted to see something. And that's why when I put on specify length, it's already sitting at 327. Okay. See where the green line stops? See where the green line stops? So let's go ahead and move that camera down. Actually, you know what? Well, screw it. Doesn't matter if you guys see this or not. Let me turn off the grids. Does the grids look a little bit funny? Just kind of screws up the view a little bit. So let's bring this down to 327. Oops. Okay. Oh, that's the top of the tape measure. Sorry. Okay. And I think I actually did these. These are not side by side. They're actually crossed. My bad. Show grids. So ready? Now, you show me the ginormous difference there between those two spots. Okay, now this let me put these a little bit more correctly here because this is the curve cam, so I want this one on the curve view curve cam. This is the flat cam. So we'll change this to the flat cam. Does anybody see a ginormous difference? Okay, now I'm going to go ahead and move this up and down. This is where it was before. This is where it is after. This is where it was before. This is where it is after. Okay, and what's actually kind of funny, if you look at the actual freeze frame, Rainier actually is a touch lower than that line. We've always said that it's even with it, but it's just a touch lower. And guess what? It is a touch lower. So basically, Antonio, I really appreciate the correction. Basically, you have made my model even more correct, and it works just as much as it did before. Now, obviously, what you were trying to say is that if we had gone lower, which, this is why you model this shit out before you make posts on my fucking channel, man. Now, let's see. What? You don't fix the bulge. The bulge is just there, dude. Did you not see the horizon go up? Watch. I'll do it again. Ready? This is the curve cam. Okay, so let me put it back where it was. The incorrect height. See this green here? And now do you see the green? Oh, let me go ahead and get this stuff out of your way before you start claiming that's something. Okay. Do you see what I'm talking about now? That is the bulge right there. Okay, as in the height of it, not the left and right side of it, because I only got so much width on it. Do you see a ginormous difference here? Yes, I see you in my chat. Do you see an enormous difference here? Now, I realize that what you're actually trying to say is because the camera was lower and because of angular size at the distances, then across a plane, it would be more probable now that Rainier was the same height as that side bulge. Well, guess what? That is the same bulge, moron. But now let's watch. Let's see exactly how far I'm going to have to go because look at here. This is across the flat one. Okay, let me make the change here. Not very much difference. Just a little bit of Rainier below the tip of St Helens. Right now, let's go ahead and try and match up the view. You have the bulge from the. I am not. All I'm doing is just in the height of the camera, dude. As you pointed out as a correction, which I thank you for. Now, let's see how to get this from the curve cam view to this on the flat view. Let's see where I have to go to get that view. Uh-oh. Oops, I got to put it back to wireframe now because we are subterranean. Wireframe. Okay. Basically, in order to get that view or something there close to, I would have to be, let's get a tape. Oops. Yeah, it would help if I'm pushing the right button here. Here's a tape. And we'll put that to there. And we'll turn off specify length. I would have to be about 740 meters below ground. Below ground. To get that view across a plane. What bulge error? There is no bulge error. You don't adjust the bulge, you dumbass. And where did, let's see, was it in the, because you posted twice and I helped you out and to ease your concentration capabilities and got rid of the second one. Let's see here. Raising the camera makes the bulge shallower. Yes, it does. Actually, it makes it lower. It doesn't necessarily make it shallower. So what bulge correction are you looking to do here? We don't bend the earth. If you don't understand how the bulge changes, it does. I just showed you it does. You know what? I'll even, well, let's see here. Let me widen this because it's obviously got you confused. Let's see. I'm going to make this extremely wide so it's all you see is its height. Okay. Now, see this? This is actually bulge. Okay. This is bulge. This is the earth curving up in front of the area there. Something you will not see because of the terrain. Okay. There's many mountains and hills between you and there. It's not like you're actually going to be picking that line out. Now, ready? I'm going to move this up. This is the difference in that bulge. Do you see that? Do you see that? Change what? Yeah, it does. You want to know how by how much? Is that what you're what are you talking about, dude? Look. Watch this. I'm going to change my view here because obviously nothing on the flat earth works. So we can pretty much hang that part up. So what I'm going to do is I'm going to put this at the curve cam. Let's see here. Oh, wait, no, actually, this has got to be front so I can get to the curve cam. Okay, here's the curve cam. This is going to be the view from the curve cam. We'll go back into smooth and highlights. And then this is going to be the entire stretch. Okay. This is the stretch between the camera, Mount Rainier, and then this is St. Helens and the Bulge. Are you, Antonio, are you paying attention to me? I'll wait for an answer. What's going on there, Jake? Hey, what's up, Rick? Factard, Darth Killer, all you guys. Okay, how do I fix the bulge? The Earth does not move when I raise or lower the camera. Watch this. Watch. Here's the curvature of the Earth. See this green line that goes down here? And this blue line? Okay. This is the curvature of the Earth. There is no bulge to move. Okay. Now, when I raise this camera, which is that camera, when I raise and lower this camera, all that does is puts a little bit more bulge in front of the view. A little bit more. Why would I need to use the Earth curve calculator? I thought that was like forbidden to use. I'm laughing at Athens. That's funny. So, okay, fine. We'll bring up the Earth curve calculator. All right, so let's see here. Metabunk. Metabunk curve. Okay, so now at the correct amount of feet, or excuse me, meters. We're doing everything in meters here. Sorry. Let's see. At the correct amount of meters, 327 meters. Let's see. Metric. 327. Okay. Now 327 meters. Now, what was that? It's like fucking some. Let's see. Hold on. I gotta get the damn measurements out. I haven't touched this model in a little while here. So I'm just going to grab a tape and we'll get to, let's see. Oops. Oh, wait, shit. What am I thinking? Not Rainier. Is 14. Oh, wait, excuse me. 104 miles. 104 miles. I'd forgotten I had that stuff on there. Let's see. Where is my 104 miles. Miles to meters. Miles to meters. 104, which is 167,372. Copy. Distance. Meters. Okay. Now let's see here. Oh, shit. 0.372, because this is in kilometers. Okay. 800 meters. Okay. So what are you looking for here, man? Now that would cover Große Feldberg, where I live. But let's see. How tall is Mount Rainier? Let's see. Mount Rainier is 4,392 meters high. Right. Okay. 4,392 meters high. And the amount of bulge, okay, which bulge isn't going to do much for you. It's hidden. So you should actually be asking me to use the hidden height. Okay. Because it's actually more. So, have fun with that. Okay. 829. It's not even a quarter of the mountain. Okay, 2718 feet bulge. Yeah, okay, we'll switch it over to imperial. Look, your bulge number isn't even right. Okay, you're talking about hidden. Do you not see, just in case anybody didn't see that, he keeps on calling that bulge. 2718 feet bulge. Don't even start with refraction on me, Rumpus. The when actually the number he's trying to state here is hidden, which is fine. Okay. But we go back to the metric, which is 829 meters. Rainier is 4,300 meters. So, what are you trying to say, man? Oh, don't use Metabunk, now use GitHub? You want to think that? Oh, jeez. What are you expecting to see, Antonio? What are you expecting to see, Antonio? GitHub Earth Calculator. Antonio, what are you expecting to see? Even you yourself have given off a measurement that's not even a quarter of the height. Well, it's about, well, it's not the height of the mountain, let's put it this way, so you would still see the mountain. What are you trying to say? Now, you are 100% right. I did fat finger the elevation of the lookout point, despite the fact that I even had it here, and it's 320 something meters. You set the bulge. You don't set the bulge. When are you going to get that? You don't set the bulge. Okay. The bulge is actually a result. Okay. It's something that you're trying to see how much it obscures. You don't set the bulge. So, like I said, yes, you offered up a correction, and I did screw up the height. I did. And guess what? It made such a ginormous difference that it's almost impossible to tell the difference. So, come on. What are you expecting to see? Now, show how much. It's right here. Do you not see this green thing here? Do you not see this green thing? I could draw you the chord. It's not going to change where the surface is. This green thing is the surface of the Earth, as modeled. Show what measurement line? Yeah, Rumpus, I don't know if you can do them in minuses. Draw what chord? Between where? Show the line between the chord and the surface. Dude, where? Where do you want a chord from? And what line do you want between the chord and the surface? Where? Camera at the new height and mount. Reindeer? Really? Reindeer? A chord through. Wait, okay. The chord from the camera at the new height and the target to the base of Rainier or to the top of it? Yes, I do know what a chord is, but you fucktard, you can't even seem to spit it out of your mouth where you want it from. Now, do you want it to the base of Rainier or you want it to the top? Hello? From the camera to the base of Rainier. Thank you. That's dude, I've been asking this for like 2 minutes. From the camera, not MSL, so from the camera to the base of Rainier at the corrected height. Okay, so let me bring it back down here to the actual correct height. Okay, now we'll draw a chord. Oh wait, because you guys love to have the target of the camera somehow changes something. Okay, so I'm going to move the target of the camera. Okay, now I have a chord between the base of Rainier and the corrected height. I'm using the center of the camera's view. Okay, are you happy now? What exactly was that supposed to prove? Sven, this is 3ds Max 2010. Okay, I have a line drawn. Now show the distance between the chord and the surface midway along the chord. Well, it actually wouldn't be midway along the chord. It would be midway from its intersect point to the other intersect point. So let me just go ahead and do this. This is one point right there where it intersects. And there. Okay, so let's go ahead and get a tape. First thing I'm going to do is I'm going to draw a tape between there and the base of Rainier. Okay, so the length of it is 142. Okay, so let's go ahead and bust this out so I don't screw this up again. So 142, 671 divided by 2 equals at 71355. So we'll just call that 71356. Specify length 71.356. That'll be the midpoint, which puts it right there. And I think I'm actually supposed to be doing this from somewhere else, but you know. So there it is right there. Now we'll go to here. Okay, like that. Okay. Now the height at the middle of the bulge is I got about 402 meters. Okay. I'm waiting for you to tell me when I was supposed to get there, man. I'm waiting for you to tell me what I was supposed to get there. Because then I'm going to tell you why you're doing this wrong. Antonio, what was I supposed to get there, man? Oops. Antonio, what was I supposed to get there? My guess is he's probably doing a live stream over there doing more talking than listening. He did that last time, at least. I don't know if he's doing it now. Antonio, what was I supposed to get here? Yeah, well, that 828 is actually hidden height. That's not this. What about 828 meters? You're talking about hidden height, right? Isn't that what came out to be the hidden height? Hold on. 829 meters, hidden height, right? Hidden height. That's what you're talking about, right? Okay, 828. Let me show you where you're screwing up, buddy. Now, what I'm going to do is I'm going to, let's see here. I'm going to zoom one of them into here. And then I'm going to zoom another one just kind of here in the middle. Okay, this was the measurement that I just did, but we ain't worried about this. This is the center of the camera line of sight, okay? Now, this says 829 meters. So what I'm going to do, see, because the measurement that you're going for is not where it's supposed to, where you think it is. Okay, so I need to set this out. Actually, I'm going to well, give me that. Okay, so tape. I'll put it a little bit in front of it so it's easier to see. Oops. So there's this. Specify length. Now that's supposed to be, we'll just go for 829. 820, oops, wow, that was going to be kilometers. 0.829 meters, right? Now that puts a line, that puts a target right there, right? So watch what happens here. I'm going to get the camera's line of sight just because I don't feel like drawing another line. And we're going to put that right there. Okay, actually we'll put it right on Rainier. Okay? And guess what? It meets up right here on the surface of the earth. That's where your measurement is made, is actually at the distance. How much of the distant target is actually covered up. Okay, so all those times that you decided you were going to write over here, 828, 828, 828, guess what? I just confirmed it. Cool? Anything else today, Antonio, that you want to get wrong? The only thing you got right, and like I said, I opened because, it's just math. Okay. I opened with saying, oops, yep, I did fat finger that number in the beginning. But guess what? It made such a ginormous difference that it was almost impossible to see. And now I just measured your hidden height, which, by the way, just so everybody can see it who decides to watch this later, he's been writing 828, 828, 828. Actually, it's 829. Okay. But at height and distance, corrected height and distance, hidden height is 829, which I just mapped out. The chord has nothing to do with the hidden height, you moron. Well, no, actually it doesn't. Do you not see what I just measured for you, Antonio? I mean, we're talking about, Antonio Subirats here. The guy who thought that multiplying was actually the power of. That shit was funny, but Come on, man. Do you not see that I just measured out your 828? Or, well, actually, 829, which is actually the number. Do you not see that I just measured that out? Nah, Surfer, I already tried that once. He ran from it. Yeah, you did a subtraction or something like that video, and oh, it was fucking hysterical. But I won't let you get off subject here. I was just highlighting your math skills. Yeah, I just punched in the wrong number. My bad. But guess what? I owned up to it. Here's me sitting here right now owning up to it. And let's not forget that across a plane, in order to get, let's see, we'll put this on flat cam, wireframe. In order to get this height relationship that we see, cameras, curve cam, that we see here, in order to get that height relationship, you have to be over 700 meters below sea level. Yeah, 700 feet. Yeah, you're right. And that was my bad. I just reversed the numbers. That's all I did. And that was my bad. And that's why I sat here and I did these numbers out for you and showed you what a ginormous difference that would have made. So now it's up to you to say why it is that you across a plane you would have to be 743 meters below the surface of the plane, below MSL, to get the same view in both across flat Earth. Flat level cam points skyward. Well, see, that's the problem there, Cosmic Surfer. This is me modeling it across a plane in order to get the view that we see actually in, hold on, actually in the photograph of the height of Rainier versus the height of that side bulge versus the height of St. Helens. The only way you're going to get that is by being over 700 meters below, meters, not feet, meters below MSL. That's why that one's pointing skywards. You're right. It would have to point skywards to get that view. Because if you look at this camera view right here, this is the flat cam, and this is the flat cam itself. Okay, see me moving it upwards like this? Okay, in order to get the view that matches what we see in the photo, you have to be some 700 plus meters below MSL. What do you mean real vision? That is perspective. That's a camera view. What the hell are you talking about? Okay, this is not an orthographic camera. This view here is not orthographic. Neither is this one. Okay, these are perspective views. I don't know what else really to tell you on that. Nah, don't need to. He ran from me last time I did that. If you would like, I can actually make it into orthographic view, but it looks kind of wonky when you do that because there's other objects there. Okay, and I can do it over on this one as well. Show the globe cam. The fuck are you talking about, Antonio? And if I do this and I put it in orthographic view, it looks all kinds of wonky. Hey, what's up there, NASAJet? Blah, 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 blah. Yeah, long name. I'm gonna start calling you Alphabet. Yeah, that'd be cool, babe. So this is pretty much all I got left. I was agreeing with the correction that was made. At first, I saw his post and I was like, "What the hell is he talking about?" But I went back and I looked, and yeah, if you want to know, for you guys who are asking, the one with the green surface is the globe cam. The one with the purple surface is the flat cam, meaning that one is across. One has all. They have both the same measurements. Just one is across a plane, and one is across the stated curvature of the Earth. What's up, Playtime? What globe cam? The curve cam? It's right here, fucktard. See this right here? Curve cam. See this right here? Flat cam. These are the views out of both of those. Oh, I agree. They're metal slugs. He'll just say that he was right and I didn't show something. I don't know what. What raise the line of sight to the Mount Rainier peak? What exactly would that do? Okay, I'm going to raise the line of sight to the Mount Rainier peak on both of them. Okay, that was on the curve cam. Oh, the flat cam's already there. What exactly were you hoping to see there, dude? Yes, Bane. IR can naming. See, because I love that argument that they're trying to have right now that somehow the direction that the camera is pointed has some kind of effect on the spatial relationship and altitude relationship, excuse me, of the distant objects. I love that argument. It's hysterical to me. I did that way back in like what, Quickie 3? There is no change in the height relationships of those objects, just where they are in the frame. That's it. So, Antonio, here's your homework because I'm pretty much done with this video. Here's your homework, Antonio. Ready? I'm going to put this back up at the corrected height across flat Earth. Okay, the corrected height of the 300 and what was it? 320, 327 meters. Okay, across a plane, which is this one right here, and then we'll put this into a nice big fat one here. Yeah, well, 720 is good. Okay, you make this match that picture. I'll give you a nickel. Okay, the purple is the peak of. Oops, trying to bring this over here. The purple is the peak of Mount St. Helens. The green is the side peak, that bulge on the side. And the red is the peak of Mount Rainier. Okay? So, you make that match somehow under some level of logic and model it out, mind you. I don't want to just hear your words about how it works and stuff like that. Nobody cares about that crap. Okay? You model it out and you make that work for me. Okay? So, ladies and gents, this went on a little bit longer than I wanted it to. I've shown the real world. No, you haven't. You haven't shown this or. Oops. Somehow that made that go full screen. Or this across a plane in the real world. You haven't done that. Okay, so don't even claim that you have. So that's basically all I got, guys. I made the correction. I stand corrected that my. No, of course you haven't shown that. Thank you for admitting that. See? Because he said right here, I've already shown real world video. And then I asked him, well, did you show this? And he goes, no, of course I haven't shown that. Well, then, hush. I've shown the photo and anyone can see. What? Whatever, dude. Anyway, Antonio made a correction, and he was right on his correction that I had miscalculated the height, even though I had all the information right in front of me. I fat fingered the height. But I went back and I made this video to correct that, leaving the old video up, and to show the ginormous difference between having a camera, between having a camera. Here's the view that we're looking for. We'll go back into solid. Okay, to show the ginormous difference between that image and that image. Okay, that image, that image. And also ensuring that you still see that this is manipulating this camera now, that to get that exact same image on flat Earth across a plane, you have to be over 700 meters below sea level. And yes, looking up. So, that's all I got, ladies and gents. Rest of this time, we got all kinds of stuff getting ready for Christmas and all that. So, I wish everybody a very Merry Christmas and stay safe. Eat a lot of food, eat a lot of sweets, and more important than that, spend a lot of time with friends and family, and make sure that everybody knows how much that you mean to them. All right? So, Frohe Weihnachten, Merry Christmas, Feliz Navidad, and y'all have yourselves a great holiday.